Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a new concept regarding model laws or similarity laws. Before going to discuss this model laws and similarity laws, I'll give a brief about the previous lecture what we have studied till now. So actually this is also a part of dimensional analysis, and in the dimensional analysis we have discussed about the dimensions and different types of dimensions are there, and after that we have discussed about the model and the prototypes. So the concept started from the model and prototype. These are the two important things are there. So we have already discussed about the what is model and what is prototype, and after that we have discussed about the forces which are acting on the moving fluids, and then next to that we have discussed about the number of dimensionless numbers. So we know that we need to first prepare a model, and then it need to be converted to the prototype before going to the practical implementation, or before going to the actual manufacturing or actual structure. Okay, you can say here actual structure, or you can say this is a before going to actual manufacturing of product. Okay, so actual manufacturing. So in the last we have seen that different types of forces which are acting on a fluid flow. Okay, so that we have discussed. So I'll give a what are the forces are there. We know that several forces like inertia force is there, and next we have gravity force, and viscous force is there, and similarly we have the forces of surface tension force, then pressure force, and one more is there, elastic force. Okay, so these are the forces we have already discussed regarding our previous lecture. When we have discussed these things, now when we have several conditions of fluid flows are there, and we need to consider some forces. The forces may be acted in the fluid single, or maybe multiple forces can be acted in the fluid flows. Now, based on these, we have also derived, or we have calculated some dimensionless numbers. So the dimensionless numbers also, it is the ratio of inertia force to the rest of the forces. Okay, so in the numbers also I'll tell like what are the numbers are there. One is Reynolds number, and next is Faraday number. So this is Faraday number, FR or FE we can say, and similarly we can write Weber number, WE, and next is Euler number, EU, and the last one is last not the least, Mach number. This is, so these are the some dimensionless numbers. Okay, so now we'll come to this picture of this model laws actually. And in the starting lecture also we discussed that what are the types of dimensions are there. Now we know that we have total three types of dimensional quantities are there. First one is geometric. First one is geometric quantities, and next one is kinematic or kinetic quantities there, and third one is the dynamic quantities. Okay, and here if you see in the geometric quantities what we have discussed about the only about the length or dimensions in terms of linear dimensions, and in kinetic we have discussed about the motions. We have discussed about the, here I'll write this shortly, we have discussed about the motions of fluid, and here we have discussed about the linear dimensions, or only you can say the dimensions of the fluid. But in dynamics we have discussed about the forces which are acting on the fluid flow. So this dynamic quantity is very much important in the fluid flow. So these are the three quantities are there, or three kind of dimensions are there. Now when we have created this model and prototype, now we'll come back to this one again. When we have created this model and prototype, so we need to satisfy all these conditions, all these geometrical conditions, like linear dimensions should be same for model and prototype. Similarly for the kinematic also, we need to check it that motion, the velocity and acceleration of these fluids need to be same for the model and prototype. Similarly in the dynamics also, the forces which are acting on the models or prototype that should be same. That means the dynamic similarity between the model and prototype, that should be same for all the points. Whatever the points we are considering, that should be equal. And as I told you, that numbers, what are the numbers we have taken here, dimensionless numbers. This is actually the ratio of forces. This is the ratio of forces. Here I'll write this one. Dimensional numbers are nothing but ratio of forces. This one already you have discussed in our previous lectures in details. So dimensionless number is nothing but the ratio of forces. That's why it is dimensionless. This actually Reynolds number will be calculated inertia force by viscous force. Similarly, Faraday number will be calculated inertia force by gravity force. So this numerator part, inertia force will be there. I'll give an example here. Suppose Reynolds number need to be calculated. We need to calculate by inertia force by viscous force. So inertia force in the numerator, that is fixed. In the denominator, all the forces will be changed for the numbers. That's it. So that means what you understood from here, the dynamic similarity between the model and prototype. The dynamic similarity between the model and prototype should be same also. But at the same time, if you see the dimensionless numbers, what we have derived in previously, dimensional numbers mean these are the numbers. Okay, should be same for models and prototypes. Okay, it means that all the numbers, these dimensionless numbers, should be same for model and prototype, because all are associated. See, the forces are associated to these numbers. So forces are very same for this models and prototype, means then the numbers also should be same for this. But the problem is it's quite difficult to satisfy the conditions of all these dimensionless numbers. Okay, because all the dimensional numbers are different. Okay, for a particular model. Okay, if suppose you have taken a model before going to the structure and manufacturing, you have taken a model and there the structure may be different or the model may be different, dimensions will be there. So at that point, what is the Reynolds number, what is the Faraday number, what is the Euler number, Mach number need to be calculated for model as well as the prototype. So it is quite difficult for all these numbers are same for the model and prototype. That's why a model are designed, different model are designed, different models are designed on the basis of what? The basis of ratio to the forces. That is designed, as I told you, this is the ratio of the forces, and that is actually mostly dominating. So the law which is actually the law on which the models are designed, that is called model laws. Very simple. The law is right here. The law on which the models are, you can say the models are designed. The law actually, what is the topic of this? The model laws or similarity laws. That means we are discussing about the similarities. But as we can see, some difficulties are identified in these numbers. Okay, so a law which is framed based on the models are designed for what? For dynamic similarities. For not for the geometric and kinematic, for dynamic, we can say, for dynamic similarities. For dynamic similarities, that is called actually model laws, or you can say the law of similarity or similarity laws. So what are the laws are there? Because this law of models are depending upon these numbers. So that's why the model laws are classified into few types. So first one I'll write. So what are the numbers we have written here? The model laws are same only. Just we need to write Reynolds. One is Reynolds model law. This is one. And second one is, what are the numbers are there? Just we'll write based on the numbers. Next is Faraday number. Next is Faraday model law. And third one is, this is Weber model law. And fourth is Euler. Fourth is Euler model law. And fifth is, this is Mach model law. This is Mach model law. So this lecture will only discuss only about one model law, that is Reynolds model law. So I'll give a heading of this, Reynolds model law. So I hope you understand why these laws are defined. Okay, why it is necessary. Because we need to satisfy all the similarities. See, in the geometric, it is mostly same. In the motion also only velocity and accelerations are there. So you can same it. Here only length or diameters or some values are there, width, breadth are there, that will be equal. But in dynamic condition, there are a number of forces are there. So that's why that difficulty came here. So in the Reynolds model laws, actually, it is based on the Reynolds number. This model law is based on the Reynolds number. So Reynolds number, what we have studied, Reynolds number we have studied that this is inertia force by viscous force. And this Reynolds number actually, this will include in where you can include this. Now we can implement this model in the pipe flow. So the flow can be inside the pipe, or we can say that is closed conduct flow, or that flow can be open channel flow. So the two things are there. Or we can say that one more application also, in suppose in the resistance experienced by the submarines, in the submarines, or you can say that is aeroplanes are there. Okay, so these some applications of Reynolds models laws are there. Now, as I told you that we have studied that the Reynolds number is nothing but inertia force by viscous force. This is the definition. So here we need to see the Reynolds number should be equal for the model, like the model what we are going to prepare, and that should be also equal for the prototype. So what we need to write here? We need to write in such a way that Reynolds number should be equal for the model and the Reynolds number should be equal for the prototype. So for this, what are the parameters are required? That means to satisfy these conditions, we need to know what is the meaning of Reynolds number and what is the formula for Reynolds number. So in the previous video, already we have discussed about the Reynolds number, that is inertia force by viscous force, and finally we got here, this is rho Vd by mu, or we can write this is on behalf of d diameter also, we can write this is rho Vl by mu, or else we can write this is Vl by nu. So these are the formula we can write here. Viscosity, kinematic viscosity is there, and here it is dynamic viscosity. That is the only difference here. So what are the terms you need to be considered to write this terminology? So we need to consider the velocity. Suppose I'll write this equation in this way. Reynolds number for model, that means I can write this is rho and this is V and this is suppose L, I will take here dimension, and divided by mu. This is for what? For model. So that means density for the model and velocity for the model and length for the model. Similarly, the viscosity for the model. That equal to, I can write rho of prototype, V of the prototype and length of the prototype, and that is with respect to viscosity of the prototype. So we need to consider here, just I'll write here with I'll use this space. Yeah, here I can write this is V, suppose Vm, this is nothing but we can write velocity of fluid, in model. Okay, and similarly we can write this is density, rho m. Rho m is nothing but density of fluid in model. Similarly, we can write this is viscosity. These are all properties, viscosity, density. Now viscosity of what? Viscosity of fluid in that particular model. And similarly length, Lm. Lm also we can write, this is length of the linear dimension we need to consider, that is dimension, geometrical properties. Okay, so Similarly, this rho p, vp, lp, and mu p accordingly we can consider for the prototypes. This is to be considered for the prototype. So these are the corresponding values of density, velocity, and length and viscosity for prototypes. Now we need to satisfy this equation. That means if both things are same, like the Reynolds number for the model and the Reynolds number for the prototype, if you are showing that it is same means, then we need to consider both this equation terms, like we can write this one. Finally, we'll get a equation that can be implemented for solving any kind of problem. That is our intention actually. So here what I can write here, I'll consider all these terms in one side. Let me consider this, all these things one side. Like here I can write, this is, again I'll write this one, like rho p, vp, and lp divided by I'll just write this is rho m and vm and lm into, this is, see, I have taken this term to this side, okay, and already in the denominator mu p is there. So if I take this one to this side, then it will go, this one mu p will be go in the numerator side. So I'll take this mu p to the denominator side, that means mu p by mu m. So that one I can write 1 by, this is mu p divided by mu m. This equal to, we can write 1. I'll tell you why I have written in this form, because I want to convert all this terminology in terms of ratio. So previously already have discussed regarding the ratio. So that is nothing but scale ratio for density. And now see, this is 1 ratio. This is 1 ratio. And this is 1 ratio. So all these things I'll tell. So I can write, finally let me write the equation, then after that I'll tell the ratio. So this is rho p by rho m. I can write this is rho r into vp by vm, that is, so we can write velocity ratio vr, and lp by lm, that is lr, that is length ratio, with respect to divided by 1 by mu p by mu m is there, that is also mu r. So this, all the things we can write, and finally we can write, make it 1. So this is our required equation. So here what I told you, I just write one thing, the remaining things you can understand. Rho r equal to rho p by rho m. And what is rho r? Rho r is nothing but, that is ratio of density. Ratio of, we can write, this is density. Similarly, this VR and LR and mu R, these are the corresponding values, corresponding ratios of, you can write, this is velocity, and this is right, we can write for the length, and this is for the viscosity. This is for viscosity. So this is our requirement to find out, to satisfy this Reynolds model law, or to satisfy this dynamic properties or similarities for the model and the prototype. So this need to be followed. And again, few more things need to be calculated. Means, suppose if you want to calculate the force, then again we need to see what is the force formula is there. Then we can say this force means, we can write force scale ratio means, we can write mass into acceleration. Then again we need to see the what is the mass of that mass ratio, again acceleration ratio. Let me write here, suppose in one line, if you want to calculate the force ratio Fr, the force ratio is the force scale ratio. So Fr, what is the formula of force here? I can write, that is mass into acceleration. So mass is what? The mass of the fluid, and acceleration of the fluid. So that also we can write mass ratio and acceleration ratio. In the mass ratio, again we can write rho av. We can convert this one, because we know that this is mass equal to, we can write rho into v, because we know that density equal to mass by volume. So mass equal to rho into v. So again we can write this is rho r, vr, and ar. Okay, rho r, ar, vr. Okay, acceleration there. Again we can write area ratio ar. So one more A will be there, which is AR. Okay. So this is the terminology. Again, we can convert this one in terms of, if you want to write in terms of r, let's suppose row r, again we can write, see, area equal to, you can write length square. Okay, so this one I can write, actually row v I have converted into this area square into, like, you know, as a value here. So area ratio, that's why I can write here row r into L square. Area part I can write LR square, and similarly this is VR into AR. So this is one just example I'm telling you, because what are the things we have derived here, so same thing we can implement in the, suppose, force. Again, if you want to calculate any kind of discharge ratio, so again we can calculate QR. QR equal to what? We know that A into V, discharge scale ratio, that is A into V. So AR and VR. Again, for this formula look there, we can calculate the discharge ratio. So this, in this method, like this is the method to calculate the or you can say to identify the value. So I hope you understand this concept of this model laws or similarity laws. Okay, if still you are having doubt in this, you can give a comment on the comment box, so I'll try to clarify your doubts. So after that, thank you. I hope you understand. All the best. Thank you.